Hello everyone, welcome to our YouTube channel for a study. So this will be the first class of geochemical lectures, and in today's class we will discuss some topics about meteorites. Okay, so let's begin. So you can see meteorites can be divided broadly, or you can say firstly we'll first discuss about what meteorites are. So meteorites are very valuable uh, because of the early solar system samples. They are very diverse and broadly classified into three types. Okay, so I'll mention the three types here. So we have the meteorites, okay, and then we have three types. We have the iron meteorite, we have stony meteorite, and we have the stony iron meteorite. Fine. So now the iron meteorite is mainly composed of Fe and nickel. So iron and nickel is there in iron meteorites. In stony meteorites, we have mostly the silicates. Okay, and in stony iron meteorites, it's a mixture of both silicates as well as we have Fe, we have nickel also. Okay, so there is iron, there is nickel, there is silicon. Whereas in stony meteorite, we only get silicon. In iron meteorite, we get Fe and we get nickel. Fine. Now, so meteorites are collected as fines and falls, and so the common type of stony meteorite. The stony meteorite can again be classified into two broad types. One is the chondrites, another one is the achondrites. Okay, so chondrites and achondrites are two types of stony meteorites. Okay, so we'll get to know what are those. Okay, before going into that, we'll discuss about two more things, which are, for example, say we have a differentiated planet. Okay, so we have a differentiated planet like this. Differentiated planet means it has a core which is made up of iron and nickel, and it has a say mantle and a crust like that, like just like earth. It is completely differentiated into different layers. Okay, this is mostly coal, sorry, this is mostly core, which is iron and nickel. This will be mainly the silicates. So we have Si here, and here we have the Fe plus Ni. Now say we get a fragment, or say this get blasted like this, and we get a fragment like this, or a meteorite like this. So what will be this composed of? This will be composed of mostly silicates, right? Whereas a section from here, if this complete blasting takes place, right, and we get different kinds of fragments, and say we get a fragment on our earth from here, what will it be? It will be mostly iron and nickel, right? Fine. So differentiated planets that explode or are hit by large asteroids can produce different types of meteorites. Okay, Now let's go to um, so we have uh, we'll discuss about iron meteorites first. Okay, iron meteorites. Okay, I'll show you some diagrams of iron meteorites so it will be better for you. So this is an iron meteorite. The second diagram I will show you. Again, this is a iron meteorite. Okay, so these two are both iron meteorites. Okay, and this type of texture, which is cross hatch texture, you can see this type of texture here, cross hatch type of texture, right? This is called Widmanstatten texture. Okay, this is called Widmanstatten texture. Okay, the image, or I will just check the spelling once. This is the definition of a Widmanstatten texture. Okay, so Widmanstatten texture, which is an intergrowth between two alloys, that is iron and nickel. When they are combined or they are intergrowth, they will form alloy and they will form a Widmanstatten texture, which is typical of iron meteorites. Fine. So this is a Widmanstatten texture only found in iron meteorites. Only found in iron meteorites. Okay. Next, we will discuss about stony iron meteorites. Okay. So stony iron meteorites includes the olivine crystals in matrix. Okay, so they have olivine crystal in matrix. Olivine crystals are there in matrix. They are possibly impact generated mixtures of core and mantle materials of a differentiated planets. Okay, so they are mixture of core and mantle material. Why core and mantle? Because we have iron which comes from core, and this is also stony which comes from the mantle. That's why it's called a stony iron meteorite. Okay, stony and iron meteorite, right? I'll again show you a picture of stony iron meteorite. This is a stony iron meteorite. Then we'll talk about lastly the stony meteorites. Okay, talk about stony meteorites. So what is the difference between stony meteorites and iron meteorites? They are composed of silicates, right? They're composed of silicates, and they have both the, they can be chondrites, they can be achondrites. So we'll come to that later. So firstly, chondrites are stony meteorites containing chondrules. Okay, so if we say about chondrites, chondrites have chondrules, right, which are granular silicate minerals like olivine and pyroxene, which probably represent molten or partially molten droplets in space. Okay, so they are mostly, chondrules are what? Chondrules are olivine and pyroxene. Okay, which represents molten or partially molten droplets in space. And so chondrites can be of different types. Okay, and what else? So some chondrites also contain, refractory inclusions of minerals rich in calcium, aluminum, titanium. So they can have calcium, which are refractory elements. Can have aluminum. They can have titanium. Okay. So chondrites mainly form from various types of dusts, then small granules, which are present in the early solar system, accreting to form the primitive asteroids. So chondrites are thus primitive and undifferentiated meteorites. Okay, so it is mostly from an undifferentiated planet or a solar body, which is undifferentiated. It is not segmented into core, mantle, crust, and completely undifferentiated. Okay, undifferentiated planetary body. When they burst out, okay, they will form chondrite, and they are formed by granules of olivine, pyroxene, which are called chondrules, and thus the name chondrites. They can have some refractory inclusions, which are calcium, aluminum, titanium. Then there are carbonaceous chondrites, which contains carbonaceous chondrites contains less than 5% of chondrites. Of all chondrites, there are carbonaceous chondrites. So we'll call it CC, which is carbonaceous chondrites, and with this represent less than 5% of all chondrites. Okay, so it's a subset of all chondrites. Very less 5% of it are carbonaceous in nature. Fine, and they are a type with at least 7 known groups are there. I'll not go into that. So all contain organic compounds like amino acids. They have, because of the carbon is actually coming from the amino acids present in the carbonaceous chondrites. Okay, and are some of all the primitive meteorites. Okay, some famous ones are like, I'll give you examples. Okay, this can be useful for UPSC GSI mains, like Alend, then or Guel and Ivuna. Ivuna is a very famous one. Okay, so the carbonaceous Ivuna, or we call it the CI, that is called carbonaceous Ivuna. Okay, so now we'll talk about the carbonaceous Ivuna. So carbonaceous Ivuna is also a chondrite that is a composition representing the solar system in its entirely and represents the bulk earth composition. So this represents the bulk earth composition. Okay, and also represents the solar system in its entirely, right? So it is the most primitive and undifferentiated meteorite. Most primitive. These points are very important for MCQ purposes. Most primitive and most and the undifferentiated meteorite. Fine. Okay. So just give you a diagram of uh, just a minute. So this is the carbonaceous Ivuna. Okay, and then we have the this is a stony meteorite. This is a stony meteorite. Okay, so this is a stony meteorite. And this is a carbonaceous Ivuna. Okay, fine. Now we will talk about the Achondrites. So Achondrite contains no chondrules and no metals and resemble the terrestrial basalts in mineral composition and texture. Okay, so what are the points? It has no chondrules, then it resembles the terrestrial basalts. It resembles terrestrial basalts. Okay, it's similar to basalts in mineral composition and textures. Okay, and they are again differentiated meteorites. So when a differentiated body which has a significant layering of core, the mantle and the crust. Okay, so when it gets blasted, then it will can form a achondrite. Okay, so it forms from a differentiated explosion of a planetary body. So they may be fragments of already differentiated planetary crust. Okay, so it can be a crustal material, it can be a mantle material. Okay, these are achondrites. So some of the examples can be, lunar meteorite. Then we have the Martian meteorite from Mars. Martian meteorite. Okay, such as example is we have the share gotites. Share gotites. Okay, which comes from Sher Ghati Gaya district in Bihar. Okay, Sher Ghati, Gaya district, Bihar. There was a meteorite impact in around 1864, right? And that meteorite is called Shergo-tites. Okay, again, very important when you're writing answers in UPSC mains. Okay, please add these kind of examples in your answers to fetch better marks. Okay. Okay, so I'll end this class up to here. So we have discussed most of the topics, right? We have discussed Achondrites, we have discussed the carbonaceous Ivuna, we have discussed stony meteorites, chondrites. Also, we have discussed the stony iron meteorites, Widman's certain texture between iron and nickel, and we have the primary classification of the different meteorites. Okay, so thank you for listening. We'll update more lectures about different topics in this channel. Okay, so please follow us, like this video, and be updated. Okay, prepare well for all your exams. Thank you.